Hey everybody, the purpose of this video is to give you a formula, if you want it, for a binomial random variable. Very often in 243 and even in 244 we kind of rely on technology to get us the values of the probabilities of the variables we're studying. And there's a very good reason for that. There's too many formulas to keep track of in the world. And in practice, there really is no need to memorize the formulas. In practice in the world, and also in classrooms for that matter. Very often shortcuts exist, algebraic shortcuts, or technology is just quicker than trying to use manual calculation. However, you might take other classes where you need to know the formula. So what I wanted to get into today was just to understand the binomial random variable. And I'll real quick throw up an example we looked at in class, which was the chicken example, my chicken flock. So you got number of girls we'll go out of 4, and the chance of that happening. And if you buy 4 birds, this was the last distribution we did together, 0, 1, 2, 3, and 4. And then we took our time and figured out the probability of each of those scenarios. So the chance of getting no girls at all was 0.1 to the 4th power. The chance of getting 1 girl, you had to get a 0.9, and then you had a 0.1 to the 3rd power. I want to come back to that. This is a 0.9 squared, and this is a 0.1 squared, again. And this is a 0.9 cubed, and this is a 0.1 to the 1st, or just 0.1 to the 0.1, 1 there. And this guy here was a 0.9 to the 4th. And actually, you know what I'm going to do? I'm going to move this guy over to put it in line with this, just to kind of show you where we're headed with this formula. I'm not going to bother multiplying these out, even though that is the most important part, and the technology does take care of it for you. But I think it's actually more helpful to see it in this form here. These aren't right, as you know, because there were those coefficients that we had to kind of laboriously get through. And these were 1, 4, 6, 4, and 1. And they were super fun to kind of figure out as far as why they needed to be there. And again, we painstakingly put them together. And I want to kind of break down this pattern into 2 pieces. One is those coefficients, and one is these probabilities over here. Okay? Now, we'll do the coefficients first. You had an entire quiz devoted to those coefficients. Total quiz for these coefficients. We'll come down here and talk about them real quick. What they are is they're called combinations, binomial coefficients, or combinations. So if you've bought 4 birds, in how many ways can you have no girls? Well, the answer is 1. There's just 1, you have all boys. If you buy 4 birds, how many ways can you have 1 girl? Well, there's 4 ways. In this case, it was either Marge or Nancy or Bertha or the last one who I can't think of, Mary. If you buy 4 birds, how many ways can you have 2 girls? And you're remembering this from class now, there are 6 ways. Mathematically, the notation for that looks like this. 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. Now, you've seen this in a couple places in this class. It was in your supercounting project, and it was also in that Pascal's quiz, if you did that one. You did the supercounting project. So there is a numerical formula for a combination. I don't think it's worth memorizing personally, but you can look back to the supercounting project to get the formula if you want it. 4 choose 0 is 1. 4 choose 1 is 4. 4 choose 2 is 6. 4 choose 3 is 4. And 4 choose 4 is 1. I know that looks like fractions. It's not. It's just this. I think it's a cool notation, but it can be frustrating for students if they've never seen it before. It's just 2 numbers floating on top of each other. And what it is, if you break it back to the example here, okay, there are usually 3 variables talked about with the binomial. I don't call them as variables in class. I just refer to them in their words. There's the sample size, which is usually called n. So you've got the sample size n, you've got the number of successes x, and you've got the probability of success on one trial p. So what I want to do is this is your sample size. This is your random variable value. And this is your probability of success on one trial. Now remember, this was done 4 times. You bought 4 birds. This is the chance of success on one trial. That was that 0.9 we kept using. So if you look at each of these combinations down here, the number 4 is on the top of each one. Okay, on the top of each one. Well, that's n. So if you wanted to generalize what you were seeing here, you're seeing n choose something underneath. You're seeing, pretend that's an n. N, it's just about as bad. N choose something. Now what are you choosing? Well, what you're choosing is, you're choosing whatever random variable is in this column, which we call x. So in a general form, the multiplier that you put out front of each one of those lines of probabilities is n choose x. In this case, 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, or 4 choose 4. But this can be extended, of course, if you have, if you have 10 chickens, or 20 chickens, or 50 chickens, however many chickens you have. If you have a Gallup poll where you're interviewing 1,000 people, 1,000. Choose however many. If you want to get half of them, it's 1,000 choose 500. If you want to get between half and all of them, it's 1,000 choose 500, 1,000 choose 501, 1,000 choose 502, up to 1,000 choose 1,000. I'm not saying you should do that. You should use technology to do that. But mathematically, that's what technology is going to do very, very quickly. So this is the first component of a formula for this. This guy right here does have a formula. And the first component of that formula is going to be n choose x. That's the binomial coefficient. I guess I should have done it in blue, but that's okay. Okay, so we're getting there. We're getting there. Now we got to talk about the probability part. Okay, now the reason I kind of moved these over and offset them was to keep the point ones together. And you might look up in here and go, well, dude, this is kind of dumb. Like, why did you just leave a space there? Well, because 0.9 to the 0 power is 1. So it actually does have a space for that 0.9 to the 0 power. Just like down here, there's a 0.1 to the 0 power. And I like having those in there because you see the pattern. 4, 3, 2, 1, 0, 0, 1, 2, 3, 4. They're moving in opposition to each other. One's going up while one's going down. Now the question I have for you is, do you see a pattern between these exponents and this variable over here? And hopefully you do. This one matches that one. This one matches that one. This one matches this one. This one matches that one. And that one matches that one. So it looks to me like that number right there is x, because x is what's in this column. And what's this number? 0.9? That's the chance of success on a trial. In this case, it's getting a chicken, but it's however you define success. So it looks to me like the next component of this formula is whatever little p is to the x power. We're getting close. We're getting close. One more factor and we're done. And choose x times p to the x power. Now we got to figure out this one. It's 0.1, 0.1, 0.1, 0.1, 0.1. Well, how do we know it was 0.1? You guys actually figured this out almost immediately. When I told you there was a 90% chance of having a girl, you said there's 10% chance of having a boy, because you knew that 1 minus p, that's sometimes called q, just FYI, sometimes they call that q, but 1 minus p is the complement, which has to be the chance of a boy, okay? But the question that I have for you guys is, what's the power here? 4, 0, 3, 1, 2, 2, 1, 3, 0, 4. What's the relationship there? What do you think? What do you think? Think about it for a couple seconds. Actually, hit pause if you want to think about it, because we're going to discuss it right now. But if you want to think about it, hit pause right now. Okay. If you hit unpause, or if you unpaused it, we can now discuss it. You see how 4 plus 0 equals 0, and 3 plus 1 equals 1, and 2 plus 2 equals... 4 plus 0 equals 4, 3 plus 1... Rewind that. 4 plus 0 equals 4, 3 plus 1 equals 4, 2 plus 2 equals 4, 1 plus 3 equals 4, and 0 plus 4 equals 4. That's interesting. If you add up those two exponents, they add up to n, which hopefully makes perfect sense. I mean, they kind of have to, right? If you have 4 birds, you have to have a split of boys and girls. You have to add together to make that 4. So it looks like whatever this exponent is right here, plus whatever exponent this is right here, and we're now calling that x, has to be equal to n. Whatever this exponent here, plus whatever exponent this is here, has to add together to make n. Well, can we solve that for the question mark? You bet we can. N minus x. And that, my friends, is the last variable up there. Let me erase a little bit over here. And that, right there, my friends, is the formula for a binomial random variable. It's actually that succinct and that kind of clear. You were doing that in class already. You were already figuring that out in class last whatever week we did that in. But this is the algebraic version of the formula. Should you ever need or want to use it, that's what the algebra looks like behind the binomial. And it's really, really cool. I mean, it's a slick formula. There's also an average and a standard deviation for the binomial. I'm going to throw them up here on the board. I want you, if you're interested, and only if you're interested, to look at them and then decide if you ever want to use them again, because you do have technology to help you. And then, if you're interested in them and you want to use them and you want to know why they work, on the enrichment page of the website, I've got justifications for both of them. So, the average for a binomial is equal to the number of trials times the probability of success. You guys figured that out almost immediately on the first day. I didn't tell you it was the formula, but you figured out that concept, which to me is more important. The standard deviation of the binomial, which is one of my favorite formulas in all statistics, is the square root of n times p times q. Or, if you want to write it like we did up there, n square root of n times p times 1 minus p, if you want to have it in terms of 2 variables instead of 3. If you want to know why both of these work, I did. When I first took my discrete math courses and my combinatorics courses, and these formulas were dropped in my lap, I wanted to know. So I went home and proved them. My work is online. By all means, check it out if you want to. But the big point of the video was to get you to that right there, because that's my favorite. It's probably my favorite, no, I shouldn't say it's my favorite. It's one of my favorite distribution formulas. But yeah, anyway, in case you need it, there it is, and we'll see you in class.